Hello, everyone. Today we will be talking about this crazy little cup of balls. It's just a standard cup, a little glass bowl which is meant to hold a candle, with two pieces of copper wire going into it and taped to the sides with alligator clips going out. And then it is connected to the to a power supply, and an LED in this sort of configuration. You might notice these two wires that are sticking out over here. Those are just, well, it'll help explain when this thing is working. But it's just a power supply that's around 3 volts in this case. The Coherer, which is this box over here, and an LED. So this shouldn't really be too interesting, right? The LED should be on, but no, it's off. And you might have seen it blinking earlier, but here I have a lighter. This is the kind with the long nozzle, and that's important. Notice the LED turned on. It's because this is a bad connection over here, and it's the type that has the trigger and the long nozzle. But the LED is off now, and let's turn out the lights so that we can see this better. Okay, so let's just make sure that light's off, and click the lighter. It turns up, and it stays on too. Tap it, give it a couple taps. It reduces in brightness quite a lot, and it gave it that. Now it's way brighter. Now it's completely off. Bright. Come on, let's give it a stir. Doesn't really work that well because, oh my goodness. There you go. Yeah. So basically, what's happening over here is that the lighter is somehow turning on this LED, and by giving it a tap, it is supposed to turn it out. Come on, there you go. There you go. So what is going on here? Well, it has something to do with these two antennas. So the lighter creates a small arc inside of the nozzle, uh, which is created by the piezoelectric igniter, and and that arc is only on for a brief moment, but it produces some electromagnetic interference, which is uh, which is picked up by these wires that are on the cup and ends up producing a voltage difference between these two electrodes. And the voltages of the supply is a very low voltage, in this case 3 volts, and the aluminum oxide balls, have a very thin layer of aluminum oxide across them, and the power supply is not strong enough to break down the oxide layer and become conductive. But the high voltage pulse that is applied across the coherer can break it down, and the circuit closes, becomes very low resistance, and the LED has enough to turn on. And the reason that it's flickering is because the oxide coating is so thin that with just a little bit of scratching and stuff, it can break and cause it to conduct. And even your voice can change it. Uh, so let's see if we can measure some of these high voltage spikes using Owen the oscilloscope. So Owen the oscilloscope is up and running, and now I can take his probe and connect it to one side of the thing. Notice there's some crazy stuff on the screen. It's because of the 60 hertz sine wave that's being picked up. And now it's basically 0, although it's slightly offset. And this should be on DC coupling, right? Where's the probe setting? Yeah, it's on DC coupling, so there's a little bit of DC voltage on there. Let's set the trigger voltage to be just above the nominal voltage level. Maybe a little bit further. Yeah, that's good. And press it on single shot mode. And let's see what happens when we click the lighter. Well, the light's turning on, but there is no voltage graphs across the screen. Very unreliable. Wonder why there aren't any voltage graphs. Maybe it just isn't too. Oh my goodness. Maybe it just isn't too sensitive. Well, maybe that's. Let's see if I can do this again. So it's set. Wait a minute. Whatever. Uh, and the trigger position is set over there. And maybe we can get a pulse. Well, it turned on, indicating that there was a high voltage pulse across it, but there is nothing on the screen. Does it have to be over a shorter period of time, perhaps? Maybe it happens just over a very short period of time. Let's try that again. No. So for some reason the oscilloscope is not triggering. Uh, I mean, I'm not sure why it wouldn't trigger, but maybe it was just completely out of view because this was okay. There you go. Maybe now we can see a high voltage pulse. Nope, the light turned on, but there is no high voltage pulse. No detectable high voltage pulse anyway. I'm not sure what that is because because in order for this to break down and conduct, there should be a high voltage pulse across it, but I'm not measuring it with the scope. So I'm not sure what that's about. And if you're concerned that the high voltage pulse might have damaged the scope, it's not really that big of a deal because the scope is in 10x mode, and it can easily measure mains voltage without a problem. I've never tried that, by the way. So you better be careful measuring mains voltage because mains voltage is kind of dangerous, believe it or not, especially if you live in a country with 220, 230, 240 volts, but in the US it's just 120, but still very dangerous. Do not try to measure mains voltage with oscilloscope. And the high voltage pulse really only needs to be maybe like 5, 10 volts to trigger the coherer and cause it to do. But anyway, that's all I have to say about the coherer effect. Bye.